myself Swati. I was working as a assistant professor in the biotech department. So now we are going to see a new topic, nanoemulsion. So now coming to the before going to nanoemulsion, first we have a small introduction about what do you mean by nanotechnology. So nanotechnology is something like it's a branch of science and engineering which leads to the creation of materials or device that will be through the manipulation of individual atoms or molecules. So as you know the word nanotechnology, so you'll be familiar with the word nanotechnology. From that itself you can get an idea like what do you mean by nanotechnology, right? So the word nano itself, it's a Latin word and it means in dark. Okay, that's a small, the size will be very small, right? So the word nano itself it indicates the size will be so small. So we are just going to deal with the particles which are the size range of nanometers, right? So the concept nanotechnology was first given by Richard Fleming. So he explained like there is plenty of room, room at the bottom. So now we just see like a new topic called emulsion. So coming to the emulsion, okay, before going to the nanoemulsion, we'll have a small discussion on emulsion. What do you mean emulsion? So emulsion is something like, as you know, like two miscible liquids will be there, right? So emulsion means two invisible liquids will be there, and they need some sort of energy or some to make them miscible or to mix it properly. We need some sort of energy or some sort of reagents we need. So normally the emulsions are the thermodynamically unstable system that consists of at least two invisible phases will be there. So one will be like dispersed phase and one will be the continuous phase. So the common examples we used to see in the normal days, we can just say the examples like milk, mayonnaise, like butter and egg. Okay. So the process of mixing the liquid in the form of an emulsion is called emulsification. So now coming to the types of emulsion. So normally it's classified into macroemulsion, microemulsion, nanoemulsion. So here we can see that it was classified on the basis of size, shape, stability, method of preparation, polydispersity. So we'll start first with size. Okay. In the case of microemulsion, the size will be from 10 to 100 nanometer, whereas in the macroemulsion that is probably from the 1 to 100 micrometer, and in the case of nanoemulsion, it will be from 20 to 500 nanometer. So next comes the shape of the emulsions. In the case of microemulsion, it will be spherical or laminar. In the case of macroemulsion, it will be spherical, and in the case of nanoemulsion, it will be spherical. And in the case of stability, we can just say like the microemulsion are thermodynamically stable, where the case of nanoemulsion and macroemulsion, they are thermodynamically unstable and kinetically stable. In the case of method of preparation, all the emulsions need some sort of energy, like depending upon the microemulsion. In the case of microemulsion, the amount of energy we need will be little less. But in the case of nanoemulsion as well as macroemulsion, we need both high and low energy we need. Next about the polydispersity index. Okay, so that will be low in the case of microemulsion, whereas in the case of nanoemulsion, the macroemulsion will be like a range of 40%, like up from 10% to 40%. Now coming to the nanoemulsion. Okay, so nanoemulsion are particles which will be the size range of 100 to 600 nanometer. Mostly it will be from like 10 to 100 nanometer. So here we need, as I told you, like there will be two invisible phases will be there, like whether it can be liquid phase or solid, like liquid phase will be there. So there will be dispersed phase or continuous phases will be there. So these both phases should be mixed properly. So how we mix it? We will be using a surfactant or as a emulsifying agent for mixing it properly. So what will happen? The surface tension between these both the phases will be getting reduced by the emulsifying agent. Here, like normally we use surfactant for mixing it properly. So next the classic, we'll just have a discussion on what is the surfactant. Okay. Surfactant compounds that lowers surface tension or the interfacial tension between two liquids. Okay, it can be any liquid or solid. So they may act as detergents, wetting agent, emulsifiers, and foaming agents. For example, as soap, fatty acid, sulfonate, like glycerin, and the both what is it? Feature of a surfactant, like how we can say it means it will be having a hydrophobic tail will be there and hydrophilic head will be there. So surfactants contain both the water insoluble compound and water soluble compound is present, and surfactant will diffuse in water and absorb the interface between the air and water or at the interface between the oil and water in the case where the water is mixed with the oil. So next coming to the different type of surfactants. So here comes like based on what based on the charges of this surfactant on the polar head. I said na there will be there will be head part will be there and tail part will be there. So depending upon the charges on the head part, it's classified into 4 types. One is anionic, cationic, superionic, and non-ionic. So in the case of anionic, the positive charge again will be there, the negative charge will be there, and the cationic will be having a positive charge, and superionic means both the negative and positive charge will be there, and non-ionic means there won't be any charge will be there. So coming to surfactant, like it plays an important role in the main application, like it plays an important role in the cleaning, wetting, dispersing, emulsifying, and forming and anti-foaming agent. It will be used in the agrochemical formulations such as herbicides and insecticides and biocides. And the personal care products like cosmetics, shampoo, shower gel, hair conditioner, toothpaste, it will be used. The surfactant used for the firefighting and the pipelines. The alkyl surfactants polymers are used in the mobilized oil in the oil mills. So now the surfactants are common, are also used for the corrosion inhibition in the ore flotation and also to promote the oil flow in the porous rock as well as to produce aerosols. Okay, so these are the examples for the anionic, cationic, non-ionic, etc. Surfactants. So this is the use of the anionic, cationic, non-ionic, etc. ions. Okay. So next is like the classification of nanoemulsions. So nanoemulsions are mostly classified into 3 types. One is oil in water, water in oil, and bicarbonate. So I have already explained, like in the case of an emulsion, there will be 2 phases will be there. One is the dispersing phase and a dispersed phase. One is the continuous phase and dispersed phase. So depending upon that, we can just see here in the case of an oil in water, the dispersed phase will be like oils will be the oils will be the dispersed phase and the continuous phase will be the water. So in the case of water and oil, the dispersed phase will be the water and the continuous phase will be the oil. The bicarbonate means the microdomains of the oil and water in the dispersed is the system. So next coming to the method used for the emulsion preparation. So as I told you, like for proper formation of an emulsion, we need some sort of energy and we need a surfactant. So here for the formulation of nanoemulsion system, we need high amount of energy. So this energy can be provided by either by mechanical element or for chemical production. So the 2 types of methods we are using for the preparation of nanoemulsion. One is high energy method and one is low energy method. In the case of low energy method, normally it's classified into 4 types. One is the phase inversion temperature, spontaneous emulsification, membrane emulsification, and emulsion bond. In the case of high energy approaches, we are using high pressure homogenizer, ultrasonic and microfluidizer. So the first week is dealing with the sonication method. So in this method, the droplet of the conversion emulsions are reduced with the help of a sonication technique. Only small batch of nanoemulsion can be prepared using this method. So next coming to the high pressure homogenizer. This is one of the high energy methods. So in this method is performed by high pressure over system having oil phase and aqueous phase and surfactant. So the pressure is applied with the help of homogenizer. And next coming to the third high pressure method, high energy method, that is microfluidization technology. Here we are using a device called microfluidizer will be used and using a high pressure positive displacement pump which will force the product to go through the chamber, which consists of small channels will be there that will help you to the pressure, the particle size will be getting reduced to small sizes. Next coming to the phase inversion method. So this is the low energy method. So here depending upon the phase transition, it will be changing this. The size will be varying about phase transition means by changing the composition or by changing the temperature, we can obtain we can reduce the size of the nanoparticles. Nanoemulsion will be formed. So next coming to the characterization of the nanoemulsion. So here we normally after synthesizing a nanoemulsion or after preparation of a nanoemulsion, we go for characterization part. The first thing is we want to check whether size is in the nano range or not. For that we will be using an analysis method called particle size analysis that will help you to know about the size of the nanoemulsion. At the same time, and next is the zeta potential. Okay, so that will be done by the surface charge measurement, and for the surface morphology or the surface pattern will be going for TEM or STEM. So next is about the viscosity of the particular nanoemulsion. So along with the characterization, it's very important to check the stability of a nanoemulsion. Why? Because when we are going for the applicative part, it's very important to know whether the nanoemulsion is stable in all the conditions. Right now we are just preparing them in a laboratory or some condition where we know, right? So when we are just exposing this one to some other conditions, like the pH may change, the temperature may change. So it's very important to find out whether this nanoemulsion being prepared is stable for a longer period or not. So the life cycle is very much important for in the case of a nanoemulsion. So stability will be performed by first we have to do the centrifugation. Later we focus on the other parameters like heat and thaw we'll be doing, deep freezing we'll be doing. So by that we can identify whether the nanoemulsion is stable or not. First we have to just split into batches and we have to just carry out all the experiment which is required for the stability parameters. So the viscosity, refractive index and droplets can be determined checked throughout the period of storage. So significant change in this parameter indicates a formulation of stability. So normally if the nanoemulsion is stable, the viscosity or the turbidity will be normal. It will be in the normal range. So once the viscosity or the turbidity is increased, that indicates the instability of a nanoemulsion. So these are the very much important parameter by checking for a stability of a nanoemulsion. So next coming to the application of nanoemulsion. So the use of normally the nanoemulsion is used in the cosmetic field, uses the cleaner, uses the vesicle for the transdermal drug delivery in cancer therapy and drug delivery, and for the vaccines, and is used as a vehicle for ocular delivery. So this is a graphical representation of how the nanoemulsion interacts with the pathogen. So normally we use it for a drug delivery purpose, or the nanoemulsion which are prepared using and the bio-based oils. We can just say like they having more antibacterial activity compared to the available antibiotics. Okay. So this is a graphical representation how the nanoemulsion is interacting with the pathogen. So normally the oil, water or water oil nanoemulsion we have prepared using high energy or low energy method. So once it's prepared and when it is interacting with the pathogen, so the interaction can be done in the three ways. Okay, one will be the passive transfer of the nanoemulsion through the cell membrane. Next will be the fusion of the help of a phospholipid layer. Otherwise, it will be an electrostatic interaction with the cell membrane. So once it is entered as the size is so small, it will be very much easy for diffuse through the bacterial cells. And once it enters inside the bacterial cell, next will be the cell lysis will be happening, like the whole the working inside like protein degradation will be happening, leakage of cell pattern will be happening, reduce the ATP, and that will finally assist to cell lysis. So thank you so much.